Hi, Physics 30. We're going to learn a little bit about displacement versus time graphs and what different things mean on a displacement versus time graph. So displacement versus time in seconds. Displacement should really have a direction. I'm going to put east, could be whatever. What really matters if we're going positive or negative. That's what's going to tell us some information. That's the difference between a vector and a scalar, that positive and negative. Okay. So distance versus displacement versus time graph. Let's look at what's happening in this first section here. Every 30 seconds, we seem to be going 150 meters. And in fact, if we calculate the slope, we're going to find something really interesting. Our change in y. Well, we went 450 minus 0 meters. Okay, and our time is 90 minus 0 seconds. Notice our units, meters per second. So really, when we calculate the slope of a displacement versus time graph, slope is really velocity. This is really important that you understand. The slope of a displacement versus time graph is velocity. So 450 minus 0 is just 450 over 90. So that is going to be 5 meters per second for this section right here. Running 5 meters per second. Now what happens between 90 and 150 right there? Well, we don't move. We stay at 450. And our time, it is 1, these are every how long? 30. So 150 minus 90 seconds. Well, we have 0 meters per second is what that would calculate to. We have no velocity at this time. So you can imagine they ran somewhere and then they stopped for 60 seconds. Okay, 150 to 240. What's going on here? It looks like we have some velocity. So it's always change in y over change in x. Our change is y, 1050 minus 450. This is meters. Oops. I don't know where that came from. There we go. Over. Our time is 240 minus 150 seconds. Okay, so we're going to have to do some calculations here. So 1050 minus 450. And we're going to divide that by bracket 240 minus 150 bracket. So 6.66. Actually, probably 6.67 is what we would do with significant figures. Okay. Notice this is steeper than this portion. So we're running faster. We have more of a velocity. Okay, here what happens? Well, we go our second value, 850 minus 1050 over 300 minus 240. Okay, so here notice that we would get negative, sorry, I'm kind of running out of space here, negative 250 over 60. So we would get a negative velocity. Here we are slowing down. A negative velocity. Sorry, we're not slowing down. We are going in the opposite direction. So we've turned around and we've had to go back because our displacement, we have to go back to 850 meters. Okay, this section right here, we're going to have a 0 velocity because we're not moving at all. So negative velocity here. Okay, I'm going to erase some of this stuff. We're running out of space. Okay, 360 to 510. So what's happening right here? Here, our slope, if you can imagine we were drawing our slope, is slowly getting steeper and steeper. So we have something that's called acceleration. Okay, and the way to remember that is anytime we have anything that looks like a smile on a displacement versus time graph, we have positive acceleration. Anytime we had any part that looked like this, we would have a negative acceleration. See, that slope is slowly getting smaller of a slope. Okay, so displacement versus time, the slope gives us our velocity. Whenever we have a curved line, we have some sort of acceleration. If we have a flat line, that means a 0 velocity.